Hello guys, welcome back to my YouTube channel. My name is Lahari, studying in Sri Venkateswara College of Engineering from the Department of CSC Data Science. Today the subject what we are going to discuss is mathematics. The topic is modular arithmetic. The content what we are going to see today is Introduction to Modular Arithmetic, Linear Congruency and Chinese Remainder Theorem. First, let's look into the introduction to modular arithmetic. Definition: modular arithmetic is a way of systematically ignoring differences involving a multiple of an integer. If n is an integer, two integers are equal to mod n if they differ by a multiple of n. It is as if multiples of n are set equal to 0. Let n, x, and y be integer. X is congruent to y in mod n if n divided by x minus y. Notation: x is congruent to y in mod n. Applications of modular arithmetic. Modular arithmetic has many applications in cryptography and computer science. It's often used to detect errors in identification numbers. Next, let's look into the next topic, that is Introduction to Congruences. Let n be a fixed positive number. Two integers a and b are said to be congruent to modulo n, symbolized by a congruent to b in mod n, which implies n divides a minus b, or a minus b is equals to k into n. Example 1. 5x congruent to 4 in mod 13, where 5x minus 4 is equals to k into 13. 5x is equals to 13 into k plus 4. X is equals to 13 into k plus 4 divided by 5. By inspection method, for k is equals to 2, x is equals to 30 by 5, where x is equals to 6. Example 2. 7x congruent to 9 in mod 15. 7x minus 9 is equals to k into 15. 7x is equals to 15 into k plus 9, where x is equals to 15k plus 9 divided by 7. By inspection method, for k is equals to 5, x is equals to 12. Example 3. Find the least positive remainder when 2 power 50 is divided by 7. Clearly, 2 cube is congruent to 1 in mod 7. Take power 16 on both sides. 2 cube whole power 16 is congruent to 1 power 16 in mod 7, where 16 threes are 48, which is 2 power 48 is congruent to 1 in mod 7, which is considered as equation 1. 2 cube is congruent to 4 in mod 7, which is considered as equation 2. From equation 1 and 2, 2 power 48 into 2 power 4 is congruent to 1 into 4 in mod 7, which is, we know the property that when the bases are equal, the powers can be added. Then 2 power 50 is congruent to 4 in mod 7. Then the least positive remainder is 4. Now let's look into the next topic, that is linear congruency. An equation of the form Ax congruent to b in mod n is called as linear congruency. Rules to find x. General format: Ax congruent to b in mod n. First, find GCD of a comma n, which is equals to d. Second, if d divides b, that is d by b, then the solution exists and there are d number of solutions. Ax congruent to b in mod n, which implies Ax minus b is equals to n into c, or Ax is equals to n into c plus b. Fourth, general solution is xk is equals to x naught plus k into n by d, where k is equals to 0, 1, 2, 3 and so on up to d minus 1. Example, solve 14x congruent to 12 in mod 14. Solution: general format is Ax congruent to b in mod n, where a is equals to 14, b is equals to 12 and n is equals to 18. First, GCD of a comma n, which is equals to 14 comma 18, which is 2. Second, clearly d by d, that is 2 by 12. Therefore, solution exists. Third, consider ax is equals to n into c plus b. 14x is equals to 18 into c plus 12. X is equals to 14 into 18 into c plus 12 divided by 14. By inspection method, for c is equals to 4, x is equals to 6, where x can be denoted as x naught is equals to 6. In general, xk is equals to x naught plus k into n by d. Xk is equals to 6 plus k into 18 by 2. N value is 18 and d value is 2. Where xk is equals to 6 plus 9k. Since d is equals to 2, therefore k is equals to 0 and 1. Then x0 is equals to 6 and x1 is equals to 15. Next, let's look into the next topic, that is Chinese remainder theorem. Chinese remainder theorem is used to solve system of linear congruencies with one variable but different moduli which are relatively prime. That is x congruent to a1 in mod n1, x congruent to a2 in mod n2, x congruent to a3 in mod n3. These three equations are considered as equation 1. Then equation 1 has unique solution, that is x is equals to a1 capital N1 into x1 plus small a2 into capital N2 x2 plus and so on in mod n1, where capital N is equals to product of n1 into n2 into n3 and so on, and capital N1 is equals to capital N by small n1, capital N2 is equals to capital N by small n2 and so on. Now let's look into the example of Chinese remainder theorem. Solve system of linear congruence, that is x congruent to 2 in mod 3, x congruent to 3 in mod 5 and x congruent to 2 in mod 7. These three equations are considered as equation 1. Here a1 is equals to 2, a2 is equals to 3 and a3 is equals to 2, and n1 is equals to 3, n2 is equals to 5 and n3 is equals to 7, where capital N is equals to small n1 into n2 into n3, where capital N gives 3 into 5 into 7, which is equals to 105. Capital N1 is equals to 105 by 3 is equals to 35. Capital N2 is equals to 105 by 5 is equals to 21. Capital N3 105 by 7, which is equals to 15. Then equation 1 can be written as 35x1 congruent to 1 in mod 3. Then 21x2 congruent to 1 in mod 5. Then 15x3 congruent to 1 in mod 7. By inspection method, 35x1 minus 1 divided by 3 gives x1 is equals to 2. Then by inspection method, 21 into x2 minus 1 by 5 gives x1 is equals to 1. Then by inspection method, 15 into x3 minus 1 divided by 7 gives x3 is equals to 1. The general equation x congruent to small a1 capital N1 x1 plus small a2 capital N2 x2 plus and so on in mod n. Then x is equals to x congruent to 2 into 35 into 2 plus 3 into 21 into 1 plus 2 into 15 into 1 in mod 105. Then x is congruent to 140 plus 63 plus 30 in mod 105. Then x is congruent to, as we add all these three numbers, we get x bar is equals to 233 in mod 105. The remainder is greater than the n value. So divide 233 by 105. We get x is congruent to 23 in mod 105. Thank you guys for watching this video. Please do like and view my video.